Hi guys, in today's lesson, I'll be calculating this JAMB chemistry question with us. A student of mine brought this question for me, gave me this question actually to solve for her. So I'll be solving it with us today so that all of us can learn and follow. Please, if this is your first time coming across my video, I want you to subscribe to my YouTube channel and also do well to follow my Facebook page at Brewwave Online Chemistry Tutorials. Now, let's get started with the question. Now, the question says a sample of orange juice is found to have a pH of 3.8. Please take note of this pH so that the value for the pH is what? Is 3.8. Now the question says what is the concentration of hydroxide ion in the juice? The question says what is the concentration of what? Of hydroxide ion in the juice. Now if you look at this question very well, this question is coming from pH under acid and base. So this question is coming from what? From pH under acid and base. Now in some of my previous video that is in my YouTube channel, I taught on what? On pH calculations. So if you have not watched those videos, I want you guys to watch those my previous video where I gave the various formulas for what? For pH, which include formulas of pH, which include where you have pH equals to what? Minus log hydrogen ion. Also have pH equals to what? N minus log A. Also have pH equals to what? N minus open bracket log S plus log Y over 2, where we have pH plus pOH equal to what? 14, where we also have pOH equals to what? Minus log hydroxide ion. You also have hydrogen ion equals to what? 10 raised to power minus pH. Also have what? Hydroxide ion, which is equals to what? 10 raised to power minus pOH. Now, in my previous video, I taught about also have what? Hydrogen ion, hydroxide ion equals to what? 1 times 10 raised to power minus 14. Now, in my previous video, I gave some of all these formulas for what? For calculating any questions at all under pH, except these two. Except what? Except these two. These two formulas were not among the formulas I gave for what? For calculating pH, except these two. Now, the rest, I gave them for what? For calculating pH in my previous video. So if you want to understand more calculation under pH, I want you guys to watch my previous video. You get full understanding of what? Of all this formula. Now, back to today's lesson. Now, the question says what? The question says, what is the concentration of hydroxide ion in the juice? From the start, it says what? A sample of orange juice is found to have what? A pH of 3.80. Now they gave us the pH to be what? 3.80, and they said what is the concentration of the what? Of the hydroxide ion in the pH. Now, if you look at this question very well, the normal way that most of us usually solve it is, or the normal formula that we use in solving this question, that most of us use in solving question like this, is this one. It is this formula that I gave here, which is this one, which happens to what? pH plus pOH equals what? 14. So this is the normal formula that most of us use for what? Calculating question like this. They give us pH here. So what we do, we'll make pOH the subject of the formula here. Then we'll find our what? Our pOH by subtracting what? Our pH value from what? From 14. So we'll get our pOH. Then to calculate our hydroxide ion here, we'll now come and use this formula. pOH equals to what? Minus log hydroxide ion. So this is the normal formula that we use. What we now find was the anti-log and get what? Our hydroxide ion. So these are the two formulas we use to calculate this question. But if you look at, for those of us that have not written JAMB before, the JAMB calculator does not have log. So how are you going to get the value for what? For log? Because you are going to, whether you like it or not, you are going to find log and anti-log. How are you not going to get the what? The value? So in today's lesson, I'll be showing us another method for calculating questions like this with ease and without stress in the JAMB examination hall. So I want you guys to stay to the end of this lesson. So I'll be introducing the formula to us now. So I'll be introducing the formula to us. Now, the question says that we should find what the concentration of the hydroxide ion. Now, this is the major formula we'll be using. Hydrogen ion, hydroxide ion. Okay, let me just divide the board now because the solving will be a little bit long. So hydrogen ion equals to what? 1 times 10 is for minus what? 14. So this is the major formula that I'll be using. Because the question says that what is the concentration of the what? Of the hydroxide ion in the juice. So they are telling us to find what the concentration of this hydroxide ion. But we don't know the concentration of the what? Of the hydrogen ion. So I'm going to find the concentration of what? Of hydrogen ion first. Using what? Using this formula, which happens to be what? Hydrogen ion equals to what? 10 raised to power what? Minus pH. So this is what? This is the formula that we'll be using to find what? Our hydrogen ion. So that we impute the value of our hydrogen ion here and get our hydroxide ion. So with this formula, we'll find what? Our hydrogen ion first. So therefore, hydrogen ion equals to what? 10 raised to power minus. Now, if you go back to the question, they said that our pH is what? 3.80. So we'll now substitute our pH here to what? 3.80. So this is it. Now, if you press this value in the calculator on 10 raised to power minus 3.80, if you press it on the calculator, you are going to get to our hydrogen ion will now be what? You're going to get 0.000 0.000158. You're going to stop here. 0.000158. So we'll now approximate it. We'll approximate it to be what? 0.00016. This 8 now approximate this 5 to become what? To become 6. So number was 0.00016 mole per dm cube. But we cannot leave our answer like this. It is better we take it to what? To standard form. So by moving it, we're going to move this. We're going to move the decimal point 1, 2, 3, and 4. The decimal point is here. So our final answer will be what? 1.6 times 10 is about minus 4. We move it 4 times. We move the decimal point from here and we move it 4 times, which happens to be what? 1, 2, 3, and 4. The decimal point is not here, so it will now become what? 1.6 times 10 is about what? Minus 4 mole per dm cube. Now, this is not our final answer, don't forget. This just happens to be what? Our hydrogen ion. This happens to be what? Our hydrogen ion. So this is what our hydrogen ion. They said that what we should find what? Our hydroxide ion. Now, having found our hydrogen ion, now let's now substitute what? This hydrogen ion into the formula and get what? Our hydroxide ion. Now, so our formula that we use is what? Hydrogen ion. Hydroxide ion equal to what? 1 times 10 raised to power minus 14. Now, our hydrogen ion that we got is what? 1.6 times 10 raised to power minus 14. And we times 10 raised to power minus 4. So to what? 1.6 times 10 raised to power minus 4. Hydroxide ion in brackets equal to what? 1 times 10 raised to power what? Minus 14. Now, they did not say we should look for what? 1.6 times 10 raised to power minus 4 hydroxide ion. They only said that we should look for what? Hydroxide ion. Now, to make hydroxide ion the subject of the formula, we are going to divide both sides by the coefficient of hydroxide ion, which happens to be what? This hydrogen ion, which have a value of what? 1.6 times 10 raised to power minus 4. So I divided both sides by what? 1.6 times 10 raised to power minus 4 over 1.6 times 10 raised to power minus 4. So this down cancel what? This up. So therefore, our hydroxide ion is equal to what? 1 times 10 raised to the power what? Minus 14 over 1.6 times 10 raised to the power what? Minus 4. So therefore our hydroxide ion equal to, now I'll be teaching you guys how to solve with standard form. That is how to solve what? pH calculations with standard form, because in the JAMB calculation hall, the JAMB calculator does not have raised to the power of, that is when you try to press 10 raised to the power, so that raised to the power of sign, JAMB calculator does not have it. So how we now press raised to the power of? So that's the reason why I'll be teaching you guys how to solve with standard form, starting from what? From this side. Now, since our hydrogen ion is now equal to what? 1 times 10 to the power minus 14 over 1.6 times 10 to the power minus 4. Now, what will now happen here is that you see this 10 to the power minus 4, I will take it up. Take it up. Now, please take note of this, that in indices, when you are taking any base that have power, that have negative power, when you are taking it up, crossing what the division sign, and if the power is with negative power, that is having a negative sign attached to it, it will change to what? A positive sign. But if it was having what? A positive sign and it's crossing division sign, it will change to what? Now it will change to what? A positive sign. Now look at it now. This 10 raised to what? Minus 4 is here. Minus is here, negative sign. Since it is crossing this division sign, it is automatically change to what? To positive sign, which is what? 10 raised to what? 4. Not 10 to what? Minus 4 again, because it is crossing what? The division sign. So what I'm explaining is this. So now be 1 times 10 raised to what? Minus 14 times 10 raised to the power 4, not minus 4 again, because if you look at this 10 raised to the power minus 4, it is crossing division sign. So because it's crossing division sign, it will not change towards positive sign, which is positive 4, not negative 4 again. Don't forget that 1.6 is still down. Don't forget. Now this 10 raised to the power minus 4, we're not taking it up. So therefore our hydroxide ion equals to, now 1 divided by 1.6. Now 1 divided by 1.6, if you divide 1 divided by 1.6, you are going to get 0.625 times 10 times 10 raised to the power. Now in indices also, so take note that when the two bases are the same, you pick one and equate the power. We have 10 raised to the power minus 14 here. We also have 10 raised to the power 4 here. Now 10, the two bases are the same. You pick one and what? Equate the power. So 10 raised to the power what? Minus 14 plus 4. Now, if you look at it very well, minus means what? You are holding, while plus means you want to pay. Now, minus 14 plus 4. Minus means you are holding, and plus means you want to pay. So, minus 14 plus 4 is minus 10. Because you are holding 14, you are paying 4. You are not holding 10. So, therefore, our hydroxide ion equals to what? 0.625 times 10 raised to the power what? Times 10 raised to the power what? Minus 10. Now, if you look at this, so therefore our hydroxide ion is now what? 0.625 times 10 raised to the power what? Minus 10. But if you look at it very well, we cannot leave on one side like this. We need to what? Move our decimal point. Now, if you move our decimal point just once, we will not get our hydroxide ion will not be what? Hydroxide ion will not be equal to what? 6.25 times 10 raised to the power what? Minus 1. Because we only move it what? Once. Then don't forget that times 10 raised to the power minus 10 is still here. Times 10 raised to the power what? Minus 10. So therefore our hydroxide ion is equal to what? 6.25 times 10. Now in indices also, don't forget, when the two bases are the same, you pick one and what? And equate the power. So now what? Raised to the power what? Minus 10 minus 1. Now don't forget, earlier on I said that minus means what? We are holding, and plus means we want to pay. Now minus 10 minus 1 is what? Is minus 11. So therefore our hydroxide ion is equal to what? 6.25. Now what will happen here is that this 5 will approximate this 2 to become 3. So now I have what? 6.3 times 10 raised to the power what? Minus 11, because minus 10 minus 1 is what? Minus 11. So now I have what? 6.3 times 10 raised to what? Minus 11 mole per dm cube. So this happens to be what? Our hydroxide ion. So 6.3 times 10 to what? Minus 11 mole per dn cube. And hydrogen ion here was what? 1.6 times 10 to what? Minus 4 mole per dn cube. But we are not concerned about what? The hydrogen ion. We only just find the hydrogen ion so that we will be able to find what? Hydrogen ion here. Our major focus was finding what? The hydrogen ion. Now the answer we got was what? This was our answer, which happens to be what? 6.3 times 10 to what? Minus 11. And of course, we are giving you options here. Option A says what? 6.3 times 10 to what? Minus 11. Option B, 6.3 times 10 to what? Minus 14. Option C, 1.6 times 10 to what? Minus 11. Option D, 1.6 times 10 to what? Minus 4. Now, if you look at it very well, most of us, now don't confuse yourself, because you just got 1.6 times 10 to what? Minus 4. And in one of the options, option D, you also have 1.6 times 10 to what? Minus 4. Now, I think that our hydroxide ion is what? 1.6 times 10 to minus 4. You have just failed the answer to the question. You have just failed it. Because we know how to find hydrogen ion. Assuming we are asked to find hydrogen ion, we'll just stop here. Was to just what? Stop here. But now we are asked to find hydroxide ion. We'll just look for it. So it was 6.3 times 10 was minus 11. Option A is 6.3 times 10 was minus 11. Of course, option A is what? Option A. Option A is what? The answer, which was 6.3 times 10 was minus 11. So this is the answer. So with this, we have come to the end of this class. If you find this video very interesting, please don't forget to subscribe to my YouTube channel, and also do to follow my Facebook page at Brewwave Online Chemistry Tutorials. So with this, we have come to the end of this lesson. Thank you guys for staying to the end. See you in my next video. Bye.